What's up, friends? Today we are here for another video in the VESCWheel DIY build series, and today I'm going to be configuring the VESC software and setting up the Onewheel as a device. Now there's a couple things that I need to do before I close this up and make sure that everything is good. I need to install the float package so that I am able to configure the lights and make sure that they're good before I permanently close. And then I also need to make sure that the foot pad wire reaches, which is part of another video, but I'm recording this during the recording of another video, if that makes sense. But anyway, this is gonna be a long video going through the setup of the VESC tool for Onewheels. I am referencing Surfdado's video. He has done a lot for the Onewheel community, so make sure you check out his channel down below in the description. He did his setup on the app on the phone. I'm going to be doing it on the desktop on the computer because that's just how I prefer to do it. So hopefully this will be valuable to some people, but I'm pretty used to VESC tools, so I think this should be fairly easy. So let's go ahead and get right into it. All right, first things first, we got our cable connected, USB-C into the little FOCer. We need to turn on the board. There we go. And we'll connect to the computer. And I will start my screen recording here. And now we can go ahead and hit the connect button. And we're connected. First things first, we're going to update the firmware. Let's see what we're on right now. I'm guessing it's 5.3. Yeah, 5.3 hardware little FOCer. So we're going to update this to 6.2. I'm not sure if, I don't know why it doesn't say anything here, but let's go read, make sure 5.03. Let's check and make sure that there's a 6.2 version for this. I'm pretty sure there is, but not 100%. And updated my VESC tool since I apparently had one that was too old. Get connected again, go to the firmware tab. It still doesn't say that it has a firmware for it for some reason. Not really sure why, but let's go ahead and download the archive and double check. There should be a 6.2 or 6.02 VESC firmware for the little FOCer. I know I saw a little FOCer listed and included files when it was not connected, so not sure what's going on here. All right, believe it or not, it's actually been like an hour since that last clip, and I've been trying to figure out what the heck was going on. Basically, the ESC wasn't showing up in VESC tool at all, which is something that I've never seen before. So thank you for that, VESC. Typical VESC moment. I tried the mobile app. I tried everything I could think of. The only thing that ended up helping me was going to Google and finding Surfdado's Github, where he has his releases. So thank you, Surfdado, for having that. And I went ahead and downloaded and installed the V6.2 version of the VESC firmware. So I went ahead and flashed the bootloader, went to custom file, and uploaded this bin. And it seems to have worked, so that's great. VESC tool still detects it as old because this VESC tool is the 6.05 one, but if I was in the 6.2 VESC tool, then it wouldn't say it was old. So from here, we can go ahead and do our first step, which is just going to be normal motor detection. So we'll go to Setup Motors FOC. And we'll just say yes, apply default settings, because I didn't have anything set at all. And now what we're going to do is we're going to go to balance. I don't think that I need to do any overrides at this time. And we're going to do large outrunner. And I don't think that I need to do an override here either. But let me double check. All right, so I do actually need to do an override here. You don't need to do any overrides here, but for the motor detection, you're going to want to set your sensorless ERPM to 2000, according to Surfdado anyway. And the hub motor in here is 30 poles. He also has his ERPM at 700, so I'm going to set that there. And yes, that is fine. And then we're going to set our battery cells in series to 18, since this is an 18S battery. And then our battery capacity is 10 amp hours because 50S cells are 5,000 milliamp hours each, and there's 2 in parallel. We're going to set this to minus 15, and the battery current max to I believe 50 was his recommendation for the meat pack, which is 50S. So I can change those later though, and we probably will. Wheel diameter, if we look at our float wheel. All right, as I was saying, if you check the diameter of the float hub, it is an 11 inch by 6.5 by 6. So 11 inches in millimeters is what we're going to need to do, which is going to be 279.40 millimeters. So we're going to set this to 280 as expected, and then make sure you hit the direct drive since this is not a geared setup. The motor thermistor, I don't know if this needs to be changed. It probably doesn't. But yeah, that's pretty much all you need. And then we're going to run detection. And since this is sitting on its side, I want to make sure I hold the rail here. And then it's going to spin up. There's no motors on CAN bus. Do the beta detection, or lambda, whatever, and then Hall sensors. And there we go, we got a successful detection. It detected at 95 motor amps, and then the rest of the values are here, and the important thing is that it detected the Hall sensors properly. So we had no issue with motor detection. There is a chart that Surfdado has in his setup video that shows typical setup values, and this is a Superflux Mark 1, and in his video he shows that typically the Mark 1 will have 27 Rmin, Rmax 35, we're right in between. Motor L min 105, max 136, we're right in between. Flex min 23.5, flex max 24.5, we're at the higher end but still in the right spot. So everything looks good. I was worried that my motor detection wouldn't work properly since I had those firmware issues, but it seems like we're all good there. So that's awesome. And now we can hit forward on here and see if it goes in forward or reverse. It does indeed go in reverse. That doesn't really matter though, since this is a balance vehicle, but I might as well do inverted just so that forward is forward if I choose to test it on the bench at any time in the future. So there you go, there's your motor detection, and now we can move on to the next part. All right, so there's a couple of values that we're going to want to change on the motor settings, and VESC likes to set things a lot lower than they need to be, or they should be, or could be. So we're going to go through here and change a little bit. So our current here, we have motor current max and min. We're going to go ahead and set our motor current max to 120. I think the Superflux can take more than that, but since I'm a noob one-wheel rider, I might as well just ride at the lower level, and then if I decide I want more power, I can always change it later because the little Fokker has built-in Bluetooth. So Dado says leave ABS current limit, slow ABS current limit on false, which is interesting because on e-skates we always leave that on true. Maybe there's something about how it cuts out on one wheels that is different. I am going to leave the absolute maximum current at the default for a little Fokker. I do not want overcurrent errors. Battery current max and min. I think I'm going to stick with what I've got here since I set that already. The 50 SL is highly capable, and I don't think we're going to be tapping 50 amps very often. But I think, at least according to Dado, you can go up to 40 amps on the min. This seems quite high, but it's pulsed super short time, so probably not a big deal. One thing to remember when you do change settings in this app is you have to hit right motor configuration over here on the right, and you get motor config updated in the bottom right. Now, voltage. This is an important one to change. For the balance vehicle type, this is new information to me, but apparently you use tilt back to manage when the board slows down, and then the voltage at the bottom here is like last resort. So what you can do is you can set the start to a number close to the end, and then the cutoff end to the very minimum. So for an 18S battery, your cell is charged to 4.2 volts at full, times 18, 75.6 is fully charged. What I would consider fully discharged for a an e-skate would be 3 times 18, 54 volts. However, since we're not riding all the way till that, we're letting the tilt back manage that, we can set this even lower to cutoff end at 2.7 times 18, which is 48.6. Ironically, it actually did already pick that number, but it set it as cutoff start. 45 volts is what? 2.5 volts per cell. That's a little uncomfortable for me. So I'm going to leave it at 2.6 volts per cell, which is 46.8. I just did that. 46.8 end, and we'll set start to 2.9 volts per cell, which is 52.2. I don't think this will cause any issues. And then we'll go ahead and write motor settings again. Now, there are ways to limit your top speed on the one wheel. I'm not going to limit mine, but you don't really want to use ERPM because you can get cutouts. Apparently there's other ways to do it, but I'm not going to worry about that. I don't think we need to do too much in temperature here. MOSFET temp cutoff start. They all set this to 75. And the motor is fine at that. That's pretty high. I hope this never reaches 95C, but that should be good. Right, motor settings. We don't actually have a BMS that's on CAN bus. It'd be cool, but I didn't want to pay all the extra for an Enoid one. Don't need to change any of these values. Fault stop time 50 milliseconds. That's pretty normal for e-skate stuff. Maximum duty cycle, I don't know if I need to change this. I'll look up some info on that. One final thing here before we go off of the general motor settings. The firmware that I've uploaded in here is actually Dado's firmware, so there may be some things that you see here that will be different than your actual default values. I did click read defaults, however, in his video he mentioned that sometimes the acceleration to temperature decrease is at 15%, you want that at 0, and then your MOSFET temp cutoffs if you have a split pack and you're running batteries in the front, the Fokker itself gets pretty hot, and I agree with him. Me personally, I wouldn't want to have it get as hot with a battery up there. And what this is really going to affect is that you may have power limited once you start getting towards those cutoffs. It'll dial back the amount of amps that it will allow you to crank when you're accelerating. So I don't really know that there's any safety concern here with setting it a little bit lower to, like, I mean, if there's batteries right there, I probably would want to have cutoff end at like 75 and start at 70, something like that. That's still uncomfortably hot if the whole heatsink were to reach that temperature, but it most likely won't. So in any case, this is motor general settings done. All right, so I'm very much following Surfdado's video here, but I'm kind of redoing it in the computer version. It looks almost the same, but it can be a little bit confusing. We're now moving on to our motor settings in FOC, and the only thing that you need to change here is change this observer gain to 0.8. If you read the little note here, the observer gain is for how smoothly the motor runs. Dado talked about motor crunch, which is kind of a weird thing that can happen at low RPM. I guess 0.8 is a good value to have here. He also mentions that your motor inductance difference should be between 30 and 60 in a healthy setup, and we appear to be good here. So all good on this first tab. There's not really anything that you need to change in the sensor list tab, so don't worry about that. Obviously we have a Hall sensor motor. The Hall sensor tab, you definitely don't want to touch this. There's nothing to change here. Don't worry about changing the Hall sensor stuff. We don't need to do anything with encoders because we don't have them. We're not running HFI, we're not running VSS. No filter changes necessary, but we do need to change some stuff in offsets. So let's do that now. All right, so for the offsets tab, the only thing you need to change here is set this to true, at least for your first couple runs. Apparently, this will help it learn the correct offsets, and then after that, you can set it to false and right. Also, one thing to remember is make sure you hit right on your motor settings to save the things that you're changing here. Next up, field weakening. This is something that we basically never use on Escape because it's super inefficient. However, on Onewheels, people use this more frequently to increase their top speed. He recommends setting this to start at 30. Now, you could, of course, just not run field weakening and see what your top speed is. I don't really anticipate reaching the top speed on this Onewheel for a while because it's going to take me a while to learn how to ride it properly. But you do have this option here, and I'm going to set it just because I want my board setup to be fully capable out of the box. So start with your field weakening at 30 amps. This does depend a little bit on how strong your battery is. It'll pump extra current into the motor essentially in order to run it at that higher speed. So it's kind of roughly how that works. All right, so for the rest of the field weakening settings, you want to have the duty start at around 65%. This is sort of like where it starts as a 0 point to start ramping in the field weakening effect per se. Let's see if the field has any info. Yeah, not really. So just set it to 65. He says don't go lower than 60, otherwise it'll start causing issues. You probably could even excuse me, go a little higher, but we'll just set it to 65. As for the ramp time, I did read somewhere that some people like closer to 500 milliseconds to have a smoother ramp in. He set his to 300, so I think I'm going to set it at about 350, and we'll see how that plays out. Again, you can change any of this really easily through the included Bluetooth in the little Fokker. All right, so apparently the Advanced tab has a couple things you can change. One of those is zero vector frequency, and there's some explanation here, but essentially what it comes down to is that the sound of the motor will change depending on what this frequency is. And Dado says it will make sound at approximately half of this frequency. So you think about like 30 kilohertz, if that's the standard, you go to a half of that, you end up with 15,000 hertz, which is pretty high pitched, but definitely ear piercing. But you can change this down. In his video, he changed it to 27 kilohertz. And then I guess sometimes you can have nose hunting issues, which is like where it doesn't know exactly what angle it's supposed to be at. And I guess incrementing this by 0.1s can fix that for resonance. But I'll put it to 27 kilohertz because that's what he put his to. And then just for reference, the frequency of that in 2 is 13.5, which to me is actually way more annoying than the 15 kilohertz. But we'll just have to see how it goes. I don't really think it's gonna make a ton of sound, but what do I know? I've never ridden a personally tuned Onewheel. You can also change the observer type, and he says that some people have had good results with Ortega Lambda. I guess this is something I can mess with later once I get more into the community, but I'm just gonna leave it on the default one and it should work. So we'll do one last motor right, and that's all the motor settings for now. So real quick, we'll go through one last thing here. The additional info section, this is where you set your wheel diameter. If you end up having issues with your GPS speed on your phone or Draggy or whatever being different than your speed that VESC tool is reading out, you can change your wheel diameter or your gear ratio a little bit to sort of tune that. Easiest to just do it by the wheel diameter. Fool VESC into thinking the wheel is bigger if you're getting slower readings, or if it's smaller if you're getting faster readings. So that's pretty simple. And then moving on to app settings. In general, this is where you can control your shutdown on momentary switch ESCs. I think there's only like one that you can do that on right now. In my opinion, momentary switch ESCs are superior because they save you if you forget to turn it off. If you leave this latched on, it'll just stay on forever and eventually kill your battery. So definitely be careful that you turn off your board after you finish riding it. But for the ones that can be controlled, this off after is the setting that will control that. That works on some of the ESCs I've used for skateboards, but hopefully we'll see a future Lil Fokker version support a momentary switch. That would be nice. Inside of UART, you don't really need to change anything. If you end up going the path where you use a remote with the Onewheel for adjusting the tilt, I believe is what he'll do. You can go into your, well, if you have it set to PWM or PPM, after you do the wizard, you can come in here and change your throttle curve and stuff like that. But other than that, that's pretty much all of that information. We do have to do some stuff with IMU, which is another thing that I never touch on the eSkate side. So we're gonna go through this setup now. Alrighty, so for our IMU setup, I just want to show you this page before we do it. If you turn on real-time IMU data on the right, you can actually see the orientation of your ESC. And if I move it, I have a box supporting it right now, but if I move it up and down, you can see it tilt, and you can also tell that it's upside down. According to that diagram on the right, you can see that the Trampa VESC there is upside down, and at about flat, you can tell that it's at an angle, and that's because the rails here are at an angle. So what we're gonna do is set it up so that it is as close to flat as you can get. It doesn't have to be perfect, but as close to flat as you can get, and then we can go ahead and start our configuration. To do that configuration, there is a wizard on the front page if you go back to welcome. you need to go to Setup IMU, and we'll start with IMU Configurator. Now we'll click Search for IMU. It actually did find it. In Dado's video, he said that most of the time it doesn't work. So interesting that it actually did work for me. And we want to set the profile to Balance Skateboard. And that is different than Balance Unicycle, that's for EUC. So we'll set that there and hit save. Next thing we've got is gyroscope calibration, and it's kind of just sitting on the desk right here. It's stable, nothing is really vibrating it. So the offsets are gonna twitch a tiny bit, but we'll just hit save and that should be good there. And then we move on to the next one. All right, so accelerometer calibration apparently is something that Dado does later. So we can skip that for right now. That's something you can use to fine tune your board. Orientation calibration we do need to do. So it is currently flat, and we can just double check this real quick with a level, but apparently the easiest way to do this is actually just to ride it and make sure that it is equal in both directions. It's actually tilted towards the back a tiny bit right now, but again, not really a huge deal for the setup because you can adjust it later. So we're not going to worry about that too much. It's close to level. So we'll hit save there. Now pitch angle, we'll wait for that to stabilize, and it stabilized at about 6 degrees. Now we want to level the roll angle, which is this way, and then pitch it to approximately 45 degrees. So you want to pull up the front of the board for this, and this should be stable there. So we'll pull this up, and that appears to have been enough. Yaw offset is set. I'll just double check. It says, yeah, okay, we're good. We'll hit save there. And that is pretty much your IMU setup done. Now we may need to come back later once we do like some tuning to set up that acceleration calibration, but for now, that's all you need to do for the IMU. All right, so one thing to check is to go back to your IMU page after you configure and check your sample rate. For me, I have a little Fokker V3, which is kind of old now, with an 800 hertz sample rate. If you have a 3.1 or some of the other ESCs, they might have an 830 or 832 or something like that. Be sure to check your manufacturer information for what your sample rate is. I know mine is correct because I have a V3. Another thing you can look at is, since the board is configured properly, if you look at that ESC graphic, you can see your level spot, and all of the real-time IMU data should be correct as well. So your angle should read out correctly, it should be in the right orientation. If that EC doesn't look like it's in the correct orientation of what your board is, you probably did something wrong. So I think this is a pretty cool visual representation of all three roll axes. And yaw is the other direction. That's only going to change when you're turning. But yeah, pretty sweet. And I'm pretty stoked with how this board is looking so far. All right, now we've got all our configuration done, it's time to install our package. So you go to your VESC packages section of the VESC tool, and the one that Dado currently recommends is Refloat. There are quite a few options in here actually. I didn't know that there were this many options, but there's apparently a large community of VESC configurations. But in any case, we're going to use the Refloat package, and just real quick, I'm going to hit Update Archive just to make sure that everything is the latest version. We'll hit Refloat and we'll hit Install. Now this should install the package onto the VESC, and this is going to allow us to write the light configuration to the Arduino. So we're going to do that in a little bit. So that did actually cause the ESC to disconnect and reconnect. And now I think, let's see, where did it go? refloat config is a separate package in here. So that's pretty cool. Let's just double check our connection firmware. Yeah, we're all good. So refloat config, this is where you're going to do all of your configuration for the refloat package. Now, one thing here, I do want to make sure that the foot pad is connected because I'm pretty sure that will be necessary. And I already found out that I'm going to have to modify this, which is pretty annoying, but it is what it is. So I'm going to disconnect, turn off the board for now, and I think what we're going to do is we're going to finish the configuration of the float package in the phone app instead. So that should be fine. And for now, we're going to sign off and finish up the assembly. All right, there's one more thing left to do in this VESC configuration video, and that is to set the voltage tilt back. So we're going to go ahead and do that right now and turn on the board. Connect up to the little Fokker, and this usually takes a couple seconds to boot into the refloat package. Got refloat config, hit yes, load custom interface, and now we can scroll over to app UI. You can see that our board is working. You can see that the foot pads turn on. You can see that the roll is where it's supposed to be. Pitch looks about right. And now we can go over to refloat config, and we're going to go not in tune, but we're going to go to specs. And in specs, we need to set the high voltage threshold. Now, this is an 18S battery, so our high voltage threshold should be about a volt or 1.5 volts over the max. So if we do 18 times 4.2, 75.6 plus 1.5, we'll do 83.1 volts. We'll just do a flat 83. And then our low voltage threshold should be our normal battery cutoff. If you remember when we were setting the official battery cutoff values, that was for when you want the board to protect the battery. This is for when you want it to tell you to stop writing. So we're going to do 3 volts per cell for this, which will be 54 volts. Oops. 54 volts. And I believe our loop hertz is fine because we set the other value in the motor config to 830. There are some other things on this page to do with LEDs, which I guess that's a new feature of refloat, but not compatible with my setup for LEDs. This is a different kind of setup, but I'll be interested to look into what this refloat LED setup is in the future. And then remember to hit write. That writes to your VESC. So now our top speed and bottom speed, our top of voltage and bottom of voltage pushbacks are set. So for the top of voltage, if you're going down a hill and it starts to overcharge the battery, it will cut off the board if it goes above 83 volts to protect the battery. And if it goes below, not cut off the board, it'll push you into pushback if it starts to go above that value. And then same thing for low voltage, it'll give you pushback or tilt back at 54 volts, which is 3 volts per cell. There's a lot of other stuff in this refloat package to go through. There's a ton of tune modifiers. There is ATR, there's startup and stop, pushback alerts, and there's also the regular tune tab, which has a bunch of different angles and boosts and all kinds of stuff. We're not going to get into any of that in today's video. I'm going to do a video with one of my friends who rides a lot on his VESC Onewheel, and we're going to look at his tune and figure out what different values do and sort of do a retune of my board after I've ridden it on the default settings for a while. I think it's always a good idea to ride on default settings to see how big of an improvement something can be or what you're missing out on. So hopefully this video is useful to anyone doing first time one-wheel VESC setup. I know this was super interesting for me since I've done setup videos for Eskate VESC in the past. This is my first one-wheel one, and I think it went pretty well. So big shout out to Surfdado. I'll link his video in the description, and to Mario Contino for his setup video. Also to some Google searches and pev.dev posts that I looked at to help me sort of learn about the one-wheel VESC setup. So thanks so much for watching, and I'm excited to ride this thing. Stay safe, keep on riding, and peace out.